Welcome to my channel again. This is Functional Skill Maths Level 2, Section B, Calculator Paper. And remember to read instructions when you're sitting for your exams. And right at the bottom here it says, if your calculator does not have a pi button, take the value of pi to be 3.14. That is very important. So the total mark for this section is 48 and for this paper is 64. So I wish you all the best if you have any exam anytime from now. Now question 1. This graph can be used to convert between gallons and liters. A. Convert 60 liters to gallons. Now we need to be able to read the graph, so we need to convert liters to gallons. So from my horizontal line, sometimes we call it the x-axis, we identify where 60 liters is. Here my 60 liters, it's here. So I'll need to trace 60 liters, draw a line straight up to meet the line in the middle. Yeah, now we trace it to gallons. It's very important to use a ruler here. That is 10, 11, 12, 13. Yes, 13. So the answer to this is 13. 13 gallons. So next question. One day, Anaya used 44 liters of fuel. Mira used 8 gallons of fuel. Anaya used more fuel than Mira. Use the graph to work out how much more. Remember to give units with your answer. This is very important whenever you're working out a question, to give units, otherwise you might lose a mark. So I will use A for Anaya, A 44 liters, and L for liters, and for Mira $8 and G for gallons. So Anaya is in liters and Mira is in grams. We need to convert them to the same unit for us to be able to compare both of them. So now if Anaya is 44 liters, here is 40, and I think here is going up in 2. How do we know if it's going up in 2 or in 1 or in 5? We need to find the difference between 40 and 50. So that is 50, take away 40, equals to 10. So you divide it by the number of lines we have in between 40 and 50. 1, 2, 3, 4, 5. So divided by 5 is equals to 2. So this will help us to know that it's going up in 2. So I can now come back and read 40, 42, 44. So my 44 is here. So now I need to draw a line up to meet the middle line and then trace it to gallons to know how many gallons it is. Okay, let's go 44. Remember to use the ruler here. And trace it to gallons. So this is 10 gallons. Now we come back to where, so 44 liters is the same thing as 10 gallons. We can actually see that we can compare now gallons here with gallons for mirror. So we see we can now say 10 gallons take away 8 gallons is equals to 2 gallons. So here we need to write 2 gallons. We could ask as well, use the liters as well. I'm going to go ahead and try liters. So if mirror is 8 gallons, 5, 6, 7, 8. So this is 8 gallons. Now we now to read what it is in liters. So we got 30, 32, 34, 36. 6 liters. So 8 gallons is 36 liters. So now I can compare 44 liters and 36 liters. So we can say 44 liters take away 36 liters is equals to 8 liters. So your answer could either be 2 gallons or 8 liters, whichever one you prefer. Question 2. David reads this advert on his country council website. 70% of the area of woodland in the country is native woodland. This means there are 350 kilometers squared of native woodland in the country. Work out the area of woodland in the country that is not native woodland. First, we know that 70% of the area is native woodland. The total area is 350 kilometers squared. And 30% is not native woodland. This is how we work it out. %70 is native woodland. Then we have 30% is not. So the total area is 340 kilometers squared. So what we first of all need to do is to find 1% of the total area. On our calculator, we do 340 divided by 70, which will give us 5 kilometers squared. This is just 1% of native land. Therefore, 30% will be 30 times 5, which we just got. That is going to give us 150. So the answer to question B is 150 kilometers squared. The scattered graph gives information about the temperatures at 8 different heights up a mountain. At a height of 1000 meters, the temperature is minus 13 degrees Celsius. Question 1a. Plot this information on the scatter diagram. So the temperature here is, that's where the temperature is, 13 minus 13, we go minus 10, 11, 12, 13. Minus 13 is here. So we need to trace this down to where it says 1000 height, which is here. Now we'll trace that. So it's important here as well in exams to use a ruler. That is 1A done. 1B. Draw a line of best fit on the scatter diagram. I've drawn my line of best fit from the first point straight down to the last point. Yours might be different from mine. You could draw from here straight down here, but you just need to make sure that the points are very close to your line of best fit. So question 3C. Use the line of best fit to estimate the difference between the temperature at the height of 550 meters and at the height of 950 meters. So we need to go back to the graph. I need to find where 550 is. It should be between 500 and 600. We need to know if the lines are going up in 10s, in 5s, or in 20s. This is how we go about it. The 600, take away 500. That'll give us 100. So divide this by the number of lines, 1, 2, 3, 4, 5. Divided by 5 will give us 20. So we know the lines are going up in 20s. So 500, 520, 540. So my 550 should be in between these two lines here. Remember, you need to be this can be very tricky in between the lines. That's where my 550 is. And remember to always use your ruler. So if I have to trace down, okay, I'm drawing a line from here, 550, down to touch the line here. Remember, use the ruler. That's it. And then I'll now trace it to read what the temperature is. So here it is. I've traced it from the line here down to here. So that is minus 6. That's minus 6. I need to do the same thing to 950. 900, 920, 940, 950 is in between here. Trace it down. Make sure your ruler is straight. Then I'll now trace it to the temperature to find what the temperature is. So I've drawn the line from here at this point to the temperature. The temperature here is minus 12. So now we need to find the difference between minus 12 and minus 6. So I'll draw a straight line down. So make sure when you're drawing you use a ruler. This is going to be my minus 12, minus 11, minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2. I've actually drawn a complete temperature for you to see the difference where the negatives are and where the positives are at the top. But what we actually need is negative 6 is here and negative 12 is here. Now we need to find the difference. 1, 2, 3, 4, 5, 6. So the answer here is 6. Now we got degree Celsius. Question 4. Here is a pentagon. The pentagon has a line of symmetry. Work out the size of the angle marked X here. So this is 125 degrees, and the angle, this is where we are looking for. Now, since we know that this side here is 90 degrees, we do 125 take away 90. In your calculator, even if you type this into your calculator, you don't just write the answer out, you need to write out your workings, which gives us 35 degrees. So here is 35 degrees. Because it says there's a line of symmetry, there's a line of symmetry down here, that means this line here is the same as this line here. Therefore, this side will be 35 degrees. So if a triangle is 180 degrees, so we need to take away both sides, both angles from 180. 180 degrees. Take away 35 degrees. We take away the other 35 degrees. Input this into your calculator and the answer is 110 degrees. Therefore, this angle here, x is 110. Question 5. Nicola wants to put a flat roof on a bike store. The roof will be made of concrete in the shape of a cuboid as shown. There's a formula given to you here. Nicholas wants to put a metal strip along two of the longest edges of the roof. That's the longest edges, is this side and this side. Work out the total mass of the concrete and the strips she wants. We need to find the formula for the total mass. From the formula given, it says density is equals to mass divided by volume. Here is the mass. We need to make sure that mass is by itself. We need to make mass the subject of this formula. To do that, we need to get rid of the volume. We times this side by volume and times this side by volume. Now we can cross this out. So we can see that mass is by itself now. So mass is equals to density times volume. Or we can rewrite it. You can rewrite it if you want. Mass is equals to density times volume. We know density equals 2,300 kilogram cubed meters. Now, what is volume? The formula for volume is length times width times height. So volume is 2 meters times 3.5 meters times 12 centimeter. We can see that the units are different, so we have to convert 12 centimeter to meters. That is 2 meters times 3.5 meters times 12 centimeter. To convert 12 centimeter to meters, so I'm going to divide 12 by 100, which will give me 0.12 meters. So if I times 2 times 3.5 times 0.12 meters, put that into your calculator, you will get 0.84 cubed. You will get 0.84 cubed meters. We now need to get the mass of concrete, which is, we know mass is equals to density times volume. Now we go volume. We know this is density. So density is 2,300 times 0.84, which will give us, put that into your calculator, 2300 times 0.84, it will give us 1932. So now we know what the mass is. We need to find the two metal strips. So both of them, both sides, 3.5 plus 3.5, which give us 7 meters. Now we know each meter is 5 kilogram. 7 times 5 will give us 35. So for both concrete and strips, we have 1932 add 35. You can easily put this in your calculator and find the answer, but we can do 2 plus 5, 7, 3 plus 3, 6, 9 plus 0, 9, 1 plus 9. So your answer is 1967 kilograms. Question 6. May has this information about 100 flowering plants in her shop. She will take a plant at random from these plants. Work out the probability that these plants will have a large flower and a long stem. From the table, you know this is the large and the long stem, so that is 29. So your answer would be 29 out of how many? We have 100 flowering plants out of 100. Question 6b. Mary will take at random a plant from the 72 plants that have a large flower. Work out the probability that this plant will have a short stem. Going back to the table. Okay, now this time around, out of 72, we have a large and a short is 43 out of 72. 43 out of 72. flowering plants. Sal walks in a dress shop. She wants to know how the labels on the dress hanger agrees with the true size of the dresses. The table shows information about some hangers and dresses. Sal thinks that 2 in every 7 dresses are on hanger with the wrong label. Is Sally correct? Show clearly why you think so. You need to find out how many dresses you have in total. So that is 12 plus 13 plus 19 plus 16 plus 17 is equals to 77. Remember I said if you type in all these numbers in your calculator and you get your answer, you still need to write the numbers down. Then we find the total of wrongly hanged dresses. Here we got 2 plus 1 plus 1, which is 4. Got 3 plus 1 plus 2 is 6. Got 2 plus 1 is 3. 1 plus 1 plus 2 is 4. 1 plus 1 plus 2 plus 1, that is 5. So we need to add all these numbers together. 4 plus 6 plus 3 plus 4 plus 5. Four plus 6 plus 3 plus 4 plus 5. Put this in your calculator and you get 22. So now we need to find out if 2 in every 7 dresses are on hanger with the wrong label. So that is going to be 22 77. To simplify it, we can simplify it. What is the common number? If we divide both by 11, divide the bottom by 11. So this is giving us 2, 7. Therefore, 2 out of 7 dresses are on hanger with the wrong label. Is Sally correct? Yes, she is correct.